Let me write down here surds. Okay, a surd is actually an irrational number, okay, that has an index which is a fraction. Okay, and this is expressed in root form. Okay, let me just give you an example of what I've just said. Okay, if you got a to the power half. Okay, typically, you know, I mean, when we write a to the power half, this can also be referred to as square root a. Okay, now what about a to the power of 3 over 2? Okay, this can be referred to as square root a to the power of 3. Okay, if you have got a to the power of, say, 2/3, alright, what you're actually doing is cube rooting a, and then that answer to the power of 2. So these are surds. Okay, these are actually irrational numbers. Okay, its index is often a fraction. Okay, and it can be expressed in root form. Okay, so surds that are similar. Okay, let me just write. There are two categories of surds: similar surds, okay, or dissimilar surds. Okay, say root 3. Sorry, wrote that down wrongly. Square root 3, okay, and 5 square root 3 are similar surds. Alright, it's got a common element, root 3. So if I tell you 5 square root 3 minus root 3, okay, now of course when I write root 3, okay, there's root 3 is actually understood to be 1 root 3. So 5 root 3 minus 1 root 3, you get 4 square root 3. Now if you were to do it with the similar surds, square root 5 and square root 7 are both dissimilar, am I right? Let me just put a comma here. Alright, they are both dissimilar, so if it's a lot, in fact you can't simplify it. Root 5 minus root 7, what's that? You can't simplify it, but if the surds are similar, you can actually simplify it. Okay, which brings me to my next point. Let me move down the page. Brings me to my next point. Okay, the laws of surds. Okay, if you take rule 1, if you take square root a times square root b, okay, you can actually multiply it and call it square root ab. This is called the multiplication of surds. I mean, you probably don't have to be too sound with the terminology here because it's mathematics we're talking about. At the end of the day, take out your textbooks, take out your assessment books, and just practice. Right, maths is all about practice. So if you have got square root a over square root b, now you can write it as square root a over b. Now this is known as the division of surds. Alright, this is known as the division of surds, and actually surds, the laws of surds are actually interlinked with that of indices. Actually, they are actually derived from the laws of indices. Okay, let me give you an example of the multiplication of surds. Okay, now if I have got 5 to the power of half times let me erase this, 6 to the power of half. Okay, although they are of different bases, okay, 5 to the power of half times 6 to the power of half can be written as square root 5 times 6. Well, let me not skip step. Let me just erase this for a moment. Okay, so square root 5 times square root 6, you get square root 5 times 6, and then your answer will be square root 30. Alright, so these are the laws of surds that you probably have to stop and think about. Let me move on to the next page here. Next page. Okay, so I spoke a little bit about similar and dissimilar surds earlier on. Okay, let's learn how to actually simplify surds. Alright, simplification of surds. Alright, we have an example here. 3 root 75 minus square root 12 plus square root 48. Now what you want to do is actually simplify it to such an extent that they have a common element. In other words, make them similar surds. Okay, how? Make them similar surds. Alright, so this can be written as square root 25 times 3 minus square root 4 times 3 plus square root 16 times 3. Alright, you can write this as 3 square root 25 square root 3 minus square root 4 square root 3 plus square root 16 square root 3. There you go. Now what's square root 25 in this case? Answer is 5. Alright, what's square root 4? Answer is 2. What's square root 16? The answer is 4. Yep. So you've simplified it into similar surds. Okay, you can write this down here. 15 square root 3 minus 2 square root 3 plus 4 square root 3. You get 15 minus 2, 13, 13 plus 4, 17 square root 3. That's your answer. Alright. So this is something you should get used to, you know. As time goes on, the more you practice, the better you get at it. Okay, let's give you another example. Okay, 6 square root 243 minus square root 12 plus 3 square root 441. Okay, you fiddle with the calculator and you know 243 can be written as 81 times 3. Alright. 12 can be written as 4 times 3. Can you see what I'm doing? I'm making them multiples of 3. And 4 for 1 is actually 49 times 9, or 49 times 3 times 3. No problem with that, isn't it? So 6 square root 81 times 3 minus square root 4 times 3. Let me try to be neat about this. Plus 3 square root 49 times 3 times 3. Alright, so it's a lot easier to simplify right now. You can write this as 6 square root 81 square root 3 square root 4 square root 3. By the way, this actually means square root 4 times square root 3, alright? Plus 3. Now square root 49. Okay, now 3 times 3 is actually 9. So square root 9. Okay, so square root 9. Okay, now you square root 81, you get 9. So 6 times 9 square root 3. Square root 4, you get 2 square root 3. You square root 9, you get 3 square root 49 times 3. Okay, 6 times 9 is 54 square root 3 minus 2 root 3 plus 9. Oops, I forgot to do this. 9 square root 49 is actually 7. Okay, so 9 times 7 times 3. There you go. Can you see it's actually looking simpler? 54 square root 3 minus 2 root 3 plus 63. Alright, and then you get 54 minus 2 is 52 root 3 plus 63. That's your answer. Alright, let's go down the page. I think we'll stop here. We'll talk about rationalizing surds in the next lesson, in the next video clip. Alright,